Hey guys and gals, this is the set. I gotta get working on it to get it off of the bench because it's crimping my style. And I tried one thing. I tried powering it with a variac, bring it up slow, and I thought maybe that would make it catch, and it didn't. So it was just like worth a try. Just wanted to try it. Now, it was suggested to me that I should just start probing out the voltages, and I guess in my last video I was mentioning about the 9 volts that power up the LED and other things, but I'll tell you why I don't want to do the probing just right now, and there's a couple reasons. One reason is that the leads here are kind of tight on here from the board to the drive board, and they don't give you much in a way. They give you like maybe like 3 inches on the high voltage lead. They don't give you much on the electrostatic ground here. But the thing is that you can't really get to this board too good because it just kind of drops in a slot, and you could get to maybe about 40% of it. So it's not an easy proposition probing it for that reason to begin with, because only part of the board's exposed, and it's kind of loose, so I'd have to tape this in somehow, keep it from moving. The other thing is that, I've seen denser boards, but it's still pretty dense, as you can see, with the leads and all that. So chances, I'm not Superman, I'm not perfect, so you go to try to probe something and you may actually touch 2 little things together and burn something out. And what good is that, So why go gung-ho trying to probe voltages, and you could actually short something out and damage something more. But my idea, when I get to that point of probing voltages, is to actually solder some little test points on different areas, and then I can use a like a clip like this when it's all powered off. I kind of clip that to like a test point, and then power it on, with the other end hooked to a meter. And I could, do things like that. Turn the power off, move it to another test point, turn it back on. That way, I think it's a lot safer for me, and it's a lot safer for the electronics than trying to probe a live circuit. That's just my intuition there. And I do have some experience working in industry. But if it was just like 5 volts, okay, I would probe that, or 12 volts. But this has a few hundred volts in different areas. It has high voltage on it. Why do I want to probe it live? It's kind of pushing it, and it's taking a risk. So what I need to do is get what they call a ESR meter for the caps that are remaining in the power supply section, etc. And ESR stands for equivalent series resistance for a cap. Now every electrolytic cap has the equivalent series resistance. And the funny thing is about these little gems is that when they get older, the electrolyte starts drying out inside of these, and it could still be in tolerance for the capacitance value in microfarads, but it's drifting out of tolerance for the ESR value, and it should be like maybe below an ohm or something, and this could creep up to maybe 10, 11, 12 higher ohms and can still test good for capacitance. So that's something I have to test for values that are in there. And you can actually test most capacitors in circuit with an ESR checker, but I need to get an ESR tester. That's what I need to do. Cowabunga! Look what magically appeared. I have to open this box, see what's in it. Okay, I got the box open. This is what I got in here. Got a whole lot of transistors. And I have all different kind of parts. Test lead stuff. It's all inclusive. Resistors. Now this is from Abco Enterprises Inc. Got it on eBay. 75 bucks, shipping included. They're the distributor for Anatech Corporation in Amherst, New Hampshire. Now I got the original idea of getting an ESR tester from a person named Bettina, and here's her channel, like right here. That's the name. But it's that she was pretty good, and she was building something from pretty much like scratch. And I said, you know, I need to like get one of those. This is a little chart here you could put on the cover. But what this will do for you is that, like I said before, you could test the ESR on these, but it does it at a low voltage at 0.6 of a volt, which is under the forward bias of diodes, or most diodes I should say. I guess some diodes are below 0.7 volts. But for most diodes, it's you will not forward bias the diodes, so you could test these little gems here, little electrolytics, in circuit. It's not going to go through the circuit and give you a wrong reading. And it's important to check the ESR on the caps. And the fact is, since electrolytics are one of your most common things to fail, you could kind of go through your electronics on the board and find the ones that are bad with the ESR rating, and just replace them and get yourself working really good, safely, and no fuss, no bother. So I have other electronics to test too, transistorized stuff, like a 4-channel receiver from the 70s I want to get going. But you know, something like this meter is going to be great to help out on that. So I'm going to get on it and build it up real quick. Okay, I got the battery hooked up to the ESR meter now, but will it work? It says initial checks. Set VR1 and VR2 to the mid-range positions. That's about mid. How about this one here? It's about mid-range. Okay. Then it says press the push button. You should see something on the 7-segment LED display. Hopefully a minus on the left-hand one. And we're going to lower the light here. Alright. Press the button again and the meter should turn off. Turn it back on and short the leads together. The meter should read less than 0.5 ohms. Okay, it's on. Short the leads together. Yeah, it reads 0.8. Okay, good. With the leads shorted, press the button again to zero the test leads. Okay. I'm out of hands. Hang on a second. Okay. Got the leads shorted with a test clip this time. Says 0.1. We gotta press it again to zero it. Oh, son of a gun, it worked. 0, 0. Okay. Then it says I gotta calibrate it now. Okay, I'll do some calibrations. I got some resistors I gotta calibrate it with. Okay, there it is too, VR2. So I adjust VR2 until it reads 82 ohms. Oop, wrong way. 81, 82. Okay, now what? Okay, now it says to use the 5.6 ohm resistor to check it out, and it should read between 5.2 and 6.0, and that decimal point should light up too. So I'm going to hook it up here. .5. Alright. Cool. Now I'm going to do final assembly and get using this bad boy. Okay, YouTube friends. I got my meter together, and it has a chart on the front. It's like a little cheat sheet chart. And on the x-axis, it has the capacitor rated voltage, and on the y-axis it has the ESR in ohms, and the lines going across here and here and here. It's the bottom line is if the cap is greater than 500 microfarad, and then this one is if it's between 100 and 500 microfarad, etc. So what I did here is that I got the caps I took out for the vertical section of the television, and I'm going to test them and see if I find a bad one, because see, this meter could work in circuit. As long as the electrolytics are discharged, you can use this meter, and it sends an AC signal into it at low voltage, and it basically it's an ACO meter. So polarity obviously doesn't matter about polarity, but I'm going to check them out. So here's the first one. This cap here, and it's 200 microfarad, 35 volts. So if I look on the chart, it should be about there. It should be 1 ESR ohms or less. Okay, so first I gotta zero out these leads. And turn it on. And then you press it again to zero it out. So let's see. I got, let's see the decimal point, I got 0.46, so it should be, let's see, it should be under 1 ESR ohm, so 0.46 is good, so that still should be good. We got this one here. I'm just going to zip through it faster here. See what this one says. The 2.0. This bad boy is 10 microfarads, so here's 10 through 100 at 50 volts, about there. So it's about, it's hard to tell on the graph. It looks like it should be under about 3. So that was a 2, so I don't know, that could be a little questionable. But you know, I could check it with this meter here. I just picked this up here. This is a you can't do this in circuit. This is a capacitance meter. So this is 10 microfarad. Let's see what it says on here. Yeah, 9.49. So this one's probably good. It shows 2 ESR ohms, and the capacitance checks out okay. But what I've been reading about, the ESR check is pretty definitive. If it's bad on ESR, then it's bad. And it still could check out good on the capacitance and still be bad on the ESR. So let me continue. So here's another one here. This is little 1 microfarad, 50 volts. Hook up the meter here. Got 2.8. So let's see. Look on the chart here. This is less than 5 microfarad. It's 10, so that one's good. Here's a big one here. This is 3,300 microfarad, 25 volts. Reads 0.03, and that's in this chart here. So it should be, I don't know, under 0.2. So it's 0.03, so that one should be good. Okay, we got this guy here. Hook this one up. Let's try delete here. Oh look, I got it hooked up. And look, it's not registering on the meter. So it's over 99 ohms. So this cap here, let's see. This cap here, get the value of this. This is 1 microfarad. This is 1 microfarad at 50 volts. So here's This is 1 microfarad at 50 volts, so it should be here about 50 ESR ohms. And when I check it out, it's definitely over 99, so this one's bad. See, I got it hooked up, but it's not registering on the meter, so that one's bad. So, just for the heck of it, let me see what it reads on the capacitance meter. It's my little Chinese capacitance meter. This costs $29, but on Amazon said it was they said it's actually pretty good. Not everything made in China is bad, but this has a very large scale integrated chip in it, and they said it's actually pretty good. It's made by a company called Honeytech. So I'm going to hook this up here. This should be 1 microfarad, and it's about 0.5 microfarad, so it's bad. So you go. I had a bad cap in the vertical section, and that was that little, the last one I replaced, the 1 microfarad that was brown colored. So that was bad. So there you go. I found a bad cap in the vertical one. So my plan of attack is to do this with the TV, is to use this meter and check out the caps in the power supply and the bypass caps too, and see if I have a bad one that shows bad ESR. Then I'll unsolder it and check it again, but this should check good in circuit because there's not enough voltage to forward bias the diode in the set. So it sure worked fine. So there you go. That's my next plan of attack, to test these caps in the power supply in circuit. And if I can't find any bad ones that way, then I'm going to have to start probing in the set and with the power on. But what I'm going to do with the set, when I come to that part, I'm going to solder little test points in various spots temporarily, these little test points in the set. Then I could hook my test lead to the set. Just take normal test lead like this, hook it into those little test point on the set, and then turn the set on and see if I got the voltage.